Can you see my screen? Excellent, good stuff. Right, okay. So all I wanted to do really today was just have a chance to get us all together and just have a look at where we're up to at the minute and pick up on a few key points and deal with any questions, queries any of you guys have got around what we're up to, where we're going, and also maybe have a little bit of a chat towards the end about what our plans might be around the internal for this particular section. So all we're going to do is just have a look at the geometry view across all the conic sections that we've studied, those 4 conic sections there, and just to see where we're up to, what our thinking is, how we're feeling about the sorts of questions that we're doing. I just wanted to reinforce, first of all, the information that you get given in the internal. So there is a lot of stuff that you're going to be given that you don't need to worry about having on a cheat sheet or anything like that. You've got all this stuff to help you with those 4 conic sections. So you've got the equation of the circle, the offset position of the center, so you've got the center and the radius. You've got the parabola, the stuff we've been looking at most recently, and the standard form of that. You've got the Cartesian and the parametric form, where the focus and directrix are. It tells you all of that. And then the ellipse and the hyperbola tends to deal with together because those two are quite similar. So you've got the plus and minus being the only real difference in there. Foci are in the same positions. This relationship between BA and C, okay, and you've got a similar relationship between BA and C down here, and then you've got the eccentricity and the asymptotes to consider. So you're given all that information, which is pretty good, because there are a lot of little formulas and little relationships to remember in this topic. So it's good that they give you bits around that. But anything else you want, you need to make a note of. So anything else would need to go down on a cheat sheet if you want to have that accessible to you. So, whether you're wanting to use what the length of the latest rectum of the parabola or the hyperbola is, then you need to have those written down to be able to use them, okay? Or anything else you think might be helpful. So what are the key things we need to be able to do, really, within this section of the topic? Well, we need to be able to get the graph if we've got the equation, and sometimes we know that means we've got to be able to complete the square if it's not given in the standard form. We've got to understand whether the symmetry of the conic we're looking at is going to be horizontal or vertical. We've got to be able to get the equation if we're given the graph or given some information, so it could be a point on the curve, that kind of thing. And that's a particularly important one, understanding what to do if you're given a point on the curve rather than just some of the sort of more typical information you might have. Understand what A, B, and C mean for each conic. What's the geometric significance of them? What are they telling you about the graph? And being able to use the right formula that connects A, B, and C. To be able to get the position of the center, the focus, the vertex, directrix, and any intercepts on the axes. Figure out what the eccentricity is and understand how the focus directrix property relates to that particular conic. So get the equation of asymptotes. This is obviously for the hyperbola, and that includes when the center is not the origin, which is the more tricky ones to do. And get the focal length, length of major axes, length of latest rectum. Using a point to determine the equation, just touch on that again, I'll give it its own point. And the only time we've really looked at tangents was right at the beginning when we were looking at circles, but being able to find the equation of a tangent to a circle, if they tell us a particular point on the circle, using the fact that we know that the angle between the tangent and radius is 90 degrees. So you may have to do that as well. And then the really big thing, the thing that the sort of internal is going to be focused on, is fitting a conic graph to a real world situation and looking at how well what you've got there fits. So that's the stuff that hopefully is just going through that, you're thinking, yeah, know about that, know about how to do that, or maybe that's something I need to brush up on a little bit more. But they're the sorts of things that you're going to need to have at your fingertips, really, in the internal to be able to deal with stuff. So I've got a few questions. I thought it might be good for us to have a run through together, and I'm going to try and do as little work as possible on this. I'm going to try and get you to suggest to me things that we should be doing on these questions. But I thought, first of all, this is your session. Are there any things particularly you'd like me to run through? Are there any questions you want us to go through together, or any things that you've been looking at, things that are bugging you that you'd want to have a look at? Deathly silence. So the one looking at fitting the conics to real life situations, Gemma. Yeah. Okay. So I know I've talked about question 3 to a number of people because that is pretty horrible. Question 3 is definitely an excellence level question, and that's fairly nasty. Are the common ones you want to have a look at from there? I mean, if you want to shout one out, Gemma, we can have a look at it. We'll just see. Let me bring the exercise up because I've got the. He says it's this one here, isn't it? Yep. Question 4. Okay, the cricket grounds. Does that look familiar? Okay. That one, number 3. Was it this one? Different one. Oh, a parabolic dish, was it? Number 11 there. Solar cooker. Okay, should we have a look at that one? Let's have a quick look at that one anyway then. And I've got a few others that just kind of bring out a few points to have a look at, so we can do that. But you know, it's your time. We can do whatever you want to in this session. So let me just take that one out. And what I will do, if I stop my PowerPoint a second, and I'll just put a new slide in there so that we can pop this one in. Come on. It's having a good hard think, isn't it, there? So we just pop that in, and we'll start from that position. Okay. All right, so all back, all on screen, yep. So we've got the solar cooker in the shape of a parabolic dish. The food is cooked by placing it at the focus F. A vertical cross-section through the center is given in the diagram below. The cooker is 80 centimeters across and 25 centimeters deep at its center, where the focus is located. Oh, I didn't bring the question over. That would have been helpful as well, wouldn't it? That's still. What was the question? Oh, determine where the focus. I have got the question. Apologies. Determine where the focus F is located. Okay. So we know for this one then, if we're going to say, makes sense to put our origin here, doesn't it? Yeah? Because we've got this vertically aligned parabola, so we know it's going to be the other way around. It's going to be x squared is 4ay. All with me? Yeah. So x squared is 4ay. We know that. What do we know? We've got that 80 centimeters there. We've got the 25 here. We can use that to work out what a is, because we know a point. Well, actually, we know 2 points that are on this graph. These 2 points at the end. Okay, and they're both giving us the same information. So the coordinates of this point is just 40, 25, isn't it? Yeah. Because we put our origin in that middle point and we know it's 80 across altogether. So that's 40, 25. So I can just sub those coordinates in to x squared is 4ay, and I should be okay getting a from that, shouldn't I? So if I've got 40 is my x, that's going to be 1600, isn't it? 40 squared, 1600. Yeah. Yep. Yep. If it was that way, I'd use y squared is 4ax. Okay, so it's understanding how the symmetry affects the equation. Yeah, so because it's a vertical parabola, we've got x squared is 4ay. If it's the usual form, the horizontally aligned one, then it's y squared is 4ax. So just, if you've got it in the other opposite orientation, just swap the letters around. Yep. Okay. That's why it went all wrong, is it? From that point. Because then it's actually not too bad, is it? Because it's 4a by 25 there. That's 100a then, isn't it? Yeah. 100a is 1600. I would expect that a is 16. Yeah. And a is the focal length. Well, that's what you're asked to find. Determine where the focus is located. Okay, so according to that, the coordinates of the focus are just 0, 16, aren't they? Okay? Is that all right? I think that's quite a lot easier than question 3. I still think question 3 is totally in the wrong place in the exercise. Because you start off doing the exercise, you think, surely it shouldn't be that hard straight off. But I'll go through, if any of you want to stay on the end and you've not already been through the bit where I've been through question 3, because I've done that with quite a few people, we can do that if you want to do that. We can go through question 3. Any others you want us to have a look at off there? 13, 14, 15. Okay, we can do a few. That's fine. Let's drop out of that then. And let's just, don't need any of my annotations. Let's have a look. So, 13, the wheels of cheese. Okay. Tell you what, let's just steal our wheels of cheese. And, oops, not in that one. Let's just get rid of that because we've dealt with that one. Let's bring our wheels of cheese in. And go again. Right, so, anyone feel happy about this one? Okay. Okay, let's have a look then. Let's bring up our pen again. So, the wheels of cheese are round when viewed from above and have an elliptical cross-section. So looking from the top, it's round, but then they've got this elliptical cross-section going on here. One of these wheels is 16 centimeters wide. Okay, 2 identical discs are cut off the top and the bottom, leaving the wheel with a flat circular top and a flat circular bottom, as shown in the diagram. The remaining piece of cheese has a diameter of 9. Sorry, has a height of 9, and the diameter of the circular cutout is 10. Calculate the height of the wheel of cheese before the discs were cut off. So it was all an ellipse, wasn't it, to start with? Yeah? That's what we know. So we know, let's have a little bit of a bad PowerPoint drawn sketch. It was an ellipse. Look at that. It's almost like the wheel of cheese, isn't it? Right. So we've got we've got that in there. What we're trying to work out is the length of the minor axis, aren't we? Yeah? The length of the minor axis of the ellipse is the height of the wheel of cheese before those bits were cut off, yeah? I know the major axis. What's the major axis on this one? 16. Yeah, that's -8 there, isn't it? And that's 8 there. So it's 16 across. So I know the major axis. But what else do I know? I know a point on the ellipse. Let's just get my pointer back so I can see where it is. Because I've chopped these bits off across the top and across the bottom around that symmetry. There is a point here on the ellipse that I know. What's the coordinates of that point? 5 and 4.5. Yeah. Does everyone see why it's 5 and 4.5? Yeah, because we've gone in our cheese, haven't we? We've gone, we've had to travel along the 5 to get to that bit at the top in the corner there, and we know that that's half the distance, half of the 9. So it's 5 and 4.5. So now we're at the point where we've got a point on our ellipse, we can use it. And our ellipse has got centre the origin, so it's a nice easy one to work with. We've got x squared over 64. We know it's like that. Everyone happy why it's x squared over 64? Yep, because the a value is 8, isn't it? From there is y squared over b squared And b is what I'm going to try and work out, because I need to double b to get my answer, and that's 1. So I sub in the point that I know. The point that I know is 5, 4.5. So I just need to sub him in. So 5, I'm going to get 25 over 64 then, aren't I? Yeah. Y squared, right, I'm going to change this into a fraction just because I find it easy to deal with. To do 4.5 squared, that's 9 over 2. 9 over 2 all squared will be 81 over 4. I'm trying to do this without a calculator. All over b squared equals 1. Now I'm just going to go 25 over 64 plus 81 over 4b squared. Happy with that? You happy with that? What I've dealt with there? $64 still. It's just because it was 8 squared, wasn't it? Yeah, I've not changed that one. I've just changed this one, but I brought the 4 into the bottom with the b squared. Yeah. If I multiply through by 4b squared, 64b squared rather, that's going to clear all my fractions. All right, in the first one, 64b squared times by this, the 64s will cancel. I'll get 25b squared, yeah? But 4's part of 64. 4 will go into 64, so I don't need to deal with that separately. I could have multiplied by 256b squared, but I don't need to, because the 64 itself will deal with the 4 on the bottom. Yeah? 4 16s, 64, so that will be fine. So what I'm going to get here is plus, because I've got the 4 on the bottom, I'll get 64 over 4, 16, and the b squares would cancel. So I'm going to get 16 lots of 81. I'm not going to work it out for the minute. Equals 1 lot of 64b squared, yeah? Why 16? Right, let me come back to that then. So I had 81 over 4. Let's just b squared. And I was multiplying by 64b squared. Yeah? B squareds go. 4 will go into 64. 16 times. Is that okay? Okay. All right. Get all the b squares onto one side. I'll leave my 16 times 81 here, and I'm leaving it as 16 times 81 for a very good reason. And what am I left with? I've taken away 25 over there. All right, so that's going to take me to 39. Yep. If I square root, that's why I kept the 16 and the 81 there, because the square root to get the b squared out, I can say that's 4 times 9. And that's root 39, b squared. But the b squared becomes a b when I've square rooted, and I've got my answer. B is going to be 36 over root 39, and then double it to get the length I want. Is that what you did? Okay, that's a bad place to mess up. Yeah. Right. Okay. Yep. That'll do it. But you see how this question again, we're saying one of the most important skills in all of this for us, certainly for the internal, because we're fitting stuff to real life situations, the most important thing for us to be able to do is to use a point that's on the curve. Yeah, if we use the point that's on the curve, we stick that into the equation, and that hopefully lets us work out what the variable we don't know is. Yeah, that's all it's going to be. So it's going to be that kind of thing time and again we're going to do. Is that okay? All right. Lots of the questions on the exercise are like that. All right. Sorry? Okay, so this is from the lesson about trying to fit conic sections. So it's the most recent one, Lyndon. Yeah, okay. It's the most recent one. But that kind of idea is what you've been using in questions where you're just given the graph in the first place, isn't it? Using the point and putting it in and working out through that. You've used that a few times in different places, but this is about just using a real life situation and imposing your conic on it so you can work with it. I've got a couple of other things just to sort of talk through and just make sure you're all happy with. And if there are other questions you want me to do from that exercise in a minute, that's fine. We can do that. But who would like to talk me through this one? How do you go about that? Can you tell me anything about the equation of the hyperbola? He dived straight in, didn't he? Can you tell me anything about the equation of the hyperbola to start off with? Yep, like that. And we know it's that way round because we know where the vertices are. Yeah? So it's x squared over a squared minus y squared over b squared. We know it's got to be that is 1. Yeah? And do a little sketch. Have a little sketch. Yeah, there's nothing wrong with having a little sketch. What does it look like? We're told the vertices are here, where that's 9, and there, well, that's minus 9. Yes. Yeah. Hang on a minute, I've misread that as well. Yeah, you're right. Thank you for... So the sketch is important, isn't it? Because we're going to go wrong. Let's get rid of that. It is the other way around. Ooh, let's... all gone wrong. Good. So the sketch is helpful. I would generally do the sketch first. So, you said it so convincingly, Michael. I just went along with you. It's such a convincing man. Right, there we go. So we know it's doing that kind of thing. And we know it's gone the other way around then. So it's y squared over b squared, if we like, minus x squared over a squared. Thank you. Okay, we know we've not got to do any offsetting with the x and the y because we've got that symmetry. We know we've got symmetry. We know it's about the origin. How do we know that? Well, we know that because it's all on the y-axis, and that's our axis of symmetry then. That's our axis of symmetry. We know we're about the origin as well because of the position of these two things. They're both offset the same distance. If it was 0, 8 and 0, minus 7, okay, we know we'd have our center in a different position. But we know with the symmetry we've got there, the center is in that spot. All right, so we're away. What do we do now? Yep. Okay. So we know it goes to the point 815. So it's this idea of using the point again. Really, really important thing for us to be able to do this kind of stuff. But before we use that point, is there anything else we can say about the equation? Okay. In this case, though, is it A or B? It's B, isn't it? Because it goes with a Y. Yeah? Because it goes with a Y in this. So we do know. Where's my... I lost my mouse pointer again. I don't know. It just disappears on me. There we are. All right, I'm down the bottom. So we know that y squared over 81 minus x squared over a squared is 1. And then it's a question really like the cheese, isn't it? Yeah, it's a different type of curve, but it's really just like the cheese. We got the point, which we're given this time. We've not had to think about too much. And then we're away. Okay, so we've got y squared, so that's 15 squared, that's 225 over 81 minus 64 over a squared is 1. What we're going to multiply by to clear the fraction? And I'm expecting you to work 81a squared, yeah. Okay, 81a Sorry? Why I do that to clear the fraction? Are you all happy to hear? Is that okay? Yeah? Why do I multiply by 81 over a squared? Because if I multiply an equation through, I know I can multiply an equation through by whatever I like, and I have to do the same on both sides, but why I choose to do it is because I don't like fractions kicking around. And I know, even if I had something simple like, let's come back over here. So if I had something simple like 1/2 minus 1/6, well, that's the third, isn't it? Yeah? A half is, 3/6, and you end up with 2/6, it's a third. But I can multiply this through to get rid of the fractions. And I just look to multiply by the common denominator. The common denominator of the 2 and the 6 is 6. If I multiply through by that, I'm going to get 3 times the 1, 3, because the 6 will have cancelled down to a 3 with that 2 on the bottom. And then there I'll get 1. Okay, and on the other side, I get 6 divided by 3 is 2. That's still true. But it's a lot easier for me when I'm working with algebra for me not to have to worry about fractions. That's why I decide to multiply the common denominator. All I'm doing is I'm looking, what's here? I've got an 81, I've got an a squared. I want to clear both of those denominators, so I multiply by the lowest, the lowest common multiple. Correct. And then you times it by a squared to clear the a squared bit. So we do it all in one go. Okay. If you want to, write it out longhand once you've done that. I mean, the important thing is that you recognize you're going to multiply by that common denominator. Okay. That's the important thing. But if you want to, there's nothing wrong with writing it out longhand and then saying, okay, that's 81a squared times by the 225 over 81. Minus 81a squared by the 64 over a squared. And then on the other side, we've got just our 81a squared times 1. Okay, and then you can think about what you can say. I'll change my colour if I do that. If I change to blue, you can think about what's going to disappear. So we're going to have the 81s cancel. 2, a 1 and a 1. The a squared is still there. The a squareds here cancel. And we've got rid of all of our fraction. So if I just write down what I'm left with, I've just got 225a squared from the first bit. That was left. And then I've got my 81 times 64. I'm just going to be a bit crafty with that like I was on the last one, because they're both square numbers. And I know this is all about squaring again. So I'm going to leave it there. Yeah, 81a squared. Then I just need to think about getting everything together. So I get my a squared together. So I take away the 81. So if I take away, whoops, I didn't mean to be there. Eraser. So if I go back to my pen and I take away the 81, so that's going to be what I'm going to be left with, 146. 144. I can't do that myself. See, it's a nice square number. I did choose this for a reason. 144. Yeah. Minus the 81 and equals 81 by 64. Square root the whole lot. Square root the whole lot. Square root the whole lot. Why bother even doing that? Why not square root the whole lot? 12a is 9 times 8. 12a is 72. A is 6. Okay? Don't bother multiplying it out because I've got these square numbers. They kick out quite nicely for me. So you could do that if you wanted to, but there's no need to do it because you've got that nice lot of square numbers. So you straight off, you've got back to your y squared over 81 minus x squared over 36. is 1, and that was your hyperbola. That's the way you'd go about it. Right. Okay. But you started doing it the same method. Yeah. And then you stuck 815 in? Yeah. Yep. Okay. Maybe there's an arithmetic error in there somewhere, Michael. Yeah. It sounds like it, 'cause it sounds like you've done the right thing. Because you've started with the equation, you've put the point in. Yeah, I mean, I've done it because I've cleared the fractions. I mean, I'm trying to do this mentally without a calculator. So I'm just trying to keep it nice and simple. And if I can avoid having decimals in there, keep the whole numbers in, and don't multiply anything I don't need to multiply because I know I'm going to be square rooting at the end, then stick with that. It just makes it a bit neater. Okay? Any other questions on that one? Yeah. Yeah, you don't really want it to be overheating on your lap, for example. Okay. Ooh. Yep, there's a nice clear area for it to get under. Yeah. Okay, right, here's another one. So, put the equation of that parabola in standard conic form. What do we need to do to it? Apart from what it says. Why is it not in standard conic form to start with? What have we got to work on getting it to look like? Well, this one's definitely got the x bit being squared, hasn't it? So it's the other orientation like the one we looked at earlier, isn't it? Okay, so how would you get it to look? Because usually you would be expecting it to look. Actually, I'm doing it that way around. X squared is 4ay, wouldn't you? For this one, x squared is 4ay. So how would you deal with this to get it to look like that? Do we need to square the bracket? What are you going to do? You need to look something like that. Something to do with x squared is something times y, or something to do with y. Might be. Have you got the latest rectum length? No, it isn't, because it's not in the standard form. Get it in the standard form, then it's easier to sketch. What do you need to do? What you're really trying to do is to get it so it says something involving x all squared equals something involving y. Well, what's it going to be? How'd you get there from there? We're going to have to divide by 8, but the minus 2 has to happen first, doesn't it? So shouldn't it look like this? Like that? Happy with that? So now I know my latest rectum length. My latest rectum length is 4a, isn't it? Well, 4a is an eighth. That's what it's telling me. What's the vertex? Sorry? Vertex is 1, 2. Yep. We've got the length of the latus rectum. Where's the focus? Now, it might help to start sketching it at this point so you don't put it in the wrong place. So we've got the vertexes at 1, 2. 1, 2. We know it's got symmetry. We know it's in the opposite form to what we're used to seeing, so it's kind of looking like that, isn't it? How can I work out where the focus is? Well, the focus is here somewhere, isn't it? One over 32. Yeah, it would, wouldn't it? Because we've got the focal length is that distance there. And that distance there is A. We know A is 1 over 32, so it's moved up an extra 1 over 32 from the 2 it was originally at the vertex. Yeah? So once you've got that, and the axis of symmetry, what's the equation of the axis of symmetry? The axis of symmetry is this thing, isn't it? What's this equation? X is 1. Yeah? Done. All right, so I'm telling you the answer. No one's listening to me. Why are they all ignoring me? That's why. So X is 1, okay, because it goes through that. It goes through the vertex. It goes through the focus. The X value is 1. All right, but we need to get it to look something like that form to start with. All right, the key thing is recognizing you've got the X bit being squared there. So that's the bit you need to isolate. And then that has to be something to do with the Y. Okay, so there's that one. All right. And sketch, yeah, it looks like that. That's a better sketch than the one I've just done. It will cross the X-axis, the Y-axis, but it crosses a bit higher up than what it might look like on my sketch. All right. Okay, here's a fitting one to a real-life situation. So this is in, I think this is in the Capitol building in Washington, D.C. And these whispering chambers, has anyone heard of whispering chambers before? Ever heard of these things? Yeah. So basically they are elliptical shaped. And if you get 2 people, one to stand at each focus, if they whisper, you can hear each other clearly. All right? Because it's an ellipse. And this ellipse could be any size. It could be a massive ellipse. But if you're stood in the foci, each of you whisper, you can hear each other clearly. Okay? And it's all to do with... Yeah. So these buildings are built like that deliberately. Okay, they're sort of special features, and people go and visit them. They're all over the world, in different places. People go and visit them just so they can actually see. I mean, obviously it's quite a majestic building as well, this one. But they go and visit them, see, to actually get this weird experience of being able to whisper and having someone who's, way away from them be able to hear clearly what they're saying. And it's all because of the focal properties of ellipses, that the stuff bounces off the ellipse and goes back through the other focus. Okay, so we've got this National Statuary Hall, and that's a picture of it. That's what it does look like. It's a fairly grand building. Its elliptical room is 40. It's American, so they're going to give us this in feet. It's 46 feet wide. It's 96 feet long. And yeah, we stand in the foci. We've got to figure out how far apart they need to stand. What's going to help us get that? What do we really need to do to find out how far apart they need to stand? Yeah, exactly. We've got A and B, haven't we? Yeah, so if we do our little sketch, we're there. We've got our ellipse. Okay, so we know the coordinates here and here and here and here. Yeah, so we've got that. So we've got A and B. So that is a 23, isn't it? And a minus 23. Yeah, and the 96 is a 48 and a minus 48. So we're out way, aren't we? Okay, so we're there. We've got A and B. Actually, we don't need to worry too much about what the equation of the ellipse is. We're trying to work out where the foci are and what's the distance between the foci. Okay, so our foci are going to be in here somewhere. All right, if we can figure out the position of one of the foci, then we can just double that x coordinate and we'll get back. What's the connection between A, B, and C? Because that's C0, isn't it? What's the connection between A, B, and C for an ellipse? Yeah, B squared is A squared minus C squared. Okay, so if we want to do that, we've now got 23 squared is 48 squared minus C squared. So we want C, don't we? So C squared is 48 squared minus 23 squared. C is the square root of that. Thank you for that, Connor. 32.13. Yep. So how far apart do they need to stand? Times it by 2. Double it. Okay. 64.2 then it's going to be, isn't it? We'll just keep it to one decimal place. Feet. Okay. So that's kind of thing, you know, using a real ellipse, figuring out what you need to do. Actually, in a lot of these whispering chambers, these whispering gallery buildings, they have the positions of the foci marked on the floor. So you're going to notice. Okay. Yeah, whoever that was. Really needs to go and have a good talk with yourself. Okay. So, last one I thought we'd have a look at together, unless you've got any other ones you want to do. Completing the square sometimes causes a problem. All right? And you may get these sorts of things. So we've got that hyperbola. How do I know it's a hyperbola rather than it possibly being an ellipse? It says. That's always a good start, Lyndon. It says. Yeah. Because we're subtracting the y squared from the x squared. If we were adding it, we'd know it should be an ellipse, all right? But nicely played there, Lyndon. Yes, it does say it. Right. So we're going to start this one. I'll go through this one, unless anyone wants to go for it. Oh, see, falling over yourselves. So we'll put all the x squared terms, the x terms to the front. So starting out, so we've got our 9x squared, we've got our 18x, we've got a minus 4y squared, and we've got 16y. And actually, I'm going to take the other bit to the other side already because I know all the numbers get collected on the other side, all the other bits. So let's have the 43 there. So to be able to complete the square, I need to just be dealing with an x squared with no coefficient in front of it. So I take the 9 out as a factor, leaves me with a 2x as well. For the next part, I'm going to do the same. I'm going to have to take that 4 out as a factor. It is a negative 4. That's y squared. Why have I gone wrong? Because this is a common mistake I've just made there. That's correct. So that's minus 4 times the plus 4 there would give me a negative 16, all right? The real danger is you see that and you copy it down onto the next row. But you've got to remember you've taken that minus 4 out as a factor. Minus 4 times what you've got here, that tells me, oh, I went wrong there. Okay, not all my mistakes are deliberate, but that one was. So that should definitely be a minus in there to make it correct. So we've got that's 43. We've now able to complete the square. Complete the square in x squared plus 2x. We know we halve the coefficient of the x, so I'd get that. Complete the square in the y squared minus 4y. Well, we half the coefficient of the y. We're going to get minus 2. So we're going to get 4y minus 2 squared. It's our 43, but now we've got to think what else has been introduced. This plus 1 at the end on the square bracket, plus 1 times the 9 has given me an extra 9. So I need to add an extra 9 onto the other side. The minus 2 squared gives me a positive 4, times by the minus 4 gives me a minus 16. I need to put a minus 16 on the other side as well. So now I've got 9x plus 1 squared, minus 4y minus 2 squared. Okay, is, what do we have? 43 plus 9, 52, take 16, 36. Almost like I chose this question to work out nicely, isn't it? It wouldn't need to. If it had been anything other than 43, we might not have been so happy. Now dividing by 36 to get an equals 1. X plus 1 squared divided by 4. Good, Michael? Yeah. Divided by 9. Yeah, because 9 over 36 is a quarter, and 4 over 36 is a ninth. And then you're done. Find the centre, vertices, foci, and the equations of the asymptotes. The asymptotes are the killer on these ones, aren't they? Yeah, the asymptotes are the real hard bits on these ones, but we should be able to do the rest fairly quickly. So let's just get those ones out first. Right, so where's the centre? Minus 1, 2, because we've offset in those positions for x and y. Right, the vertices, I would probably write down A and B before I do anything else. A is 2, B is 3, yeah? Okay, I can work out C. Let's do that while we're here. This time it's a hyperbola, so it's c squared minus a squared. It's that way around, yeah? Okay, so c squared is a squared plus b squared if I like. So I've just got to get c squared is root 13. C squared is 13, rather, c is root 13. All right, I already knew a squared and b squared. There were 4 and 9, so I've just got 13. C is root 13. Right, now I can start to think about where the vertices are going to be. And I would do a little sketch to start and help yourself out with this. Let's do a little sketch down here. Let's start with our sketch, and we have, we know where our centre is, minus 1, 2. So let's do a minus 1 and a 2 is there. Okay, we know it's the usual form. We're going to go this way round. We know then this is our axis of symmetry. We've got going on there. This is the axis of the hyperbola, rather. So we know our vertices and our foci are going to be on that line, don't we? Yeah. Who can give me the coordinates of one of the vertices? Okay, we're after a vertex to start with. Yeah. One and minus 4. So you're stepping it. Where are you stepping it? Doesn't the vertex need to be along this dotted line? So the y coordinate's got to be 2, hasn't it? What's the x coordinate? Oh, sorry, I thought you were giving me a coordinate there. Sorry, right. Sorry. Yeah, I'm asking. Okay, you're right. That's a 1 and a minus 4. Sorry, that's me. Bit slow there. Okay, there's your minus 4. Yeah, I thought that's an odd coordinate. You've moved 2 things there. Right. Yeah, so they're at 1 and minus 4, and I can get the position of the foci because I know they have to move 2/13, don't they? So they have to move beyond that position. So I'm going to get actually if I give a general form for my foci, if I like, rather than trying to figure out what they are, I still know that the y-coordinate is going to be 2, but the x-coordinate is going to be -1 plus or minus √13. Because I'm moving √13 along from the center to get that, and it's 2. All right, so my foci are along here somewhere, back there and back there. Okay, the equations of the asymptotes, that's the tricky bit. Where do we start with that, though? How would we start doing that? Okay, so you can use the y minus y1 is mx minus x1, but what's your gradient? Yeah, so our gradients, we end up with 2 possible ones, don't we? Plus or minus b over a are going to work out for us here. So this time it's 3/2, isn't it? And then all you've got to do is stick the point in. The danger is that you try and give these both by just using the 3/2. You've really got to work through this twice, because rather than them being centered about the origin, which they were before we offset to move to this position, they're now going to be doing other things, yeah? Because you're going to have your asymptotes doing that and doing that. So you can't just work out, the intercepts for one of them and then assume that's the same intercept for the other, because it isn't. You've not got that anymore. So you need to start with your point, and the point that you know is on both is which point? What's on both? The center, isn't it? Yeah, -1, 2. So you just start and you put that in. But you have to put that in both. So we've got y minus y1, y minus 2 is 3/2 lots of x. Well, that'd be -3/2 then, wouldn't it? And we'd also got, oops, sorry, I'm doing this, 3/2 x minus 1. And then go from there. So that's given us the -3/2. We add the 2 on. We've got 3/2 plus a half then, haven't we? 3/2x plus a half. And then you do the same on the negative gradient. Y minus 2 is -3/2 x minus 1. Still have to add the 2 on to the other side, but the other side this time was a 3/2 because of the minus times a minus. So the number was a 3/2. You've added another 2 onto that. You'll have 7/2, or 3.5 if you like. Okay, it's the asymptotes are the trickier bit. Is that all okay? Yep. The thing where people go wrong on these ones, and it's early on, isn't it? Yeah, if you're going to go wrong, it's going to be there probably. All right, so just watch that. That's the bit to watch. You're never going to get that problem on an ellipse question because you haven't got the minus in front of the y squared. But on a hyperbola question, that's where it's going to come and bite you if you're not careful. All right. Okay, so there is going to be on Friday an open mini book. A mini open book assessment, rather. So we'll run that in Dr. Frost on Friday. There are some questions that let you see how you're getting on. It's going to be across everything to do with the geometry that we've looked at so far on the conics. We've not finished the conics topic yet. We're not at the point where we're ready for the internal. There is some more stuff that we need to do where, funnily enough, we've been doing calculus since February. We actually haven't done any calculus yet, really. We've not done any integrating or differentiating. We need to do some calculus, and that occurs in the conics for the first part. So there's a bit of calculus for us to do, a bit of differentiating. But we'll do that on Friday. We'll have this little mini assessment, just see how we're getting on. I've put some review questions together that started today in Dr. Frost that just call Working with Conic Sections Review Exercise. So there are some new questions I've put in there just to allow you to prepare. If you want to have a go at those and have a bit of a play, you can do that. So we're going to be looking at this on Friday. The next lesson we would have is Thursday. Thursday you can just practice. Okay, you've got that review exercise. If there are other things you want to be looking at and catching up, that's you can build that in as well. But that review exercise does cover everything. All right, everything is in there, all the sorts of things we've been looking at. So on Friday, though, we'll do the little assessment. And the final thing I've just put on here is just thinking about the internal. And I don't necessarily want an answer from you now, and it might be better for us to look after we've done the mini assessment anyway. So maybe when we catch up next week and have a bit of a chat, but just to think about how you feel. Having done the mini assessment, you'll know where you're at with your understanding, how well placed you feel for the internal. And we've still got some more material to do before we're going to be there, and we've got practices to do before we're going to be there. And we may be back in school. So it may become a non-issue, but we might want to start thinking in any case, if we're not back in school, what are we going to want to do? Are we going to feel happy as a group doing the internal remotely? Because I know those of you who do stats have been looking at doing that with Mr. Burns. But also, we need to think carefully about what the impact of us not doing it is. If the lockdown goes on for any period of time, what kind of knock-on effect it might have to the other topics that we need to do, the other internals and externals that we obviously got coming up as well. So I just wanted to set you thinking about that really more than anything. Don't need an answer from you now. If you want to say something now, by all means, say something now. But I think certainly we need to have a conversation about it after we've done the mini assessment, just so we see where everyone is and what you're thinking. It might be a bit clearer then. Does that seem fair enough? Okay. Did you want me to go for anything else today? I know we've gone over time, haven't we, by a couple of minutes? I'll put the video up for this as well, so it's all up there for those who missed. Has it been useful getting together? Yeah? Okay, that's good then, because again, it's come out of the survey, and hopefully it was going to be useful. And we'll do this, we'll do this once a week, or at least once a week, so we can get stuff together. But do keep dropping in onto the Google Meets if you want help and stuff like that. It's always good to see you, always good to have a chat and talk over stuff. And what I'm saying, you're doing good stuff. So not ideal, not perfect situation for anybody, but you're doing yourselves credit with what you're doing at the minute. So good job, guys. Okay. I will see you next time then. Take care. See you, mate.